We can also solve a system algebraically using either substitution or elimination. If we're going to use substitution, we want to isolate a variable with a coefficient of 1. Y is the easiest one to isolate, which you'll see in a second. If you're trying to eliminate a variable, then try to eliminate the y's, because you can see that we now have an x squared and an x as well as a constant term and this y in here. So if we can eliminate the y, we're going to be left with a quadratic equation, which we can then solve by either factoring or using the quadratic formula. So in my first equation here, if I want to isolate y, I'm going to move that 3x over and it's going to become negative 3x. If I want to isolate this y, I'm going to move over my squared term and I'm going to move over my x term, so those signs are going to change. And we can now see that we have y equals and y equals. We're essentially going to substitute one of those equations into the other in the place of y, making the two sides equal to one another. And you can now see that we have a degree 2 equation, which means it's going to be a quadratic. So to solve a quadratic equation, we want to move all terms to the side where this squared term is positive. So because it's a negative right now, I'm going to move everything over to the left, and we're going to set that equal to 0. And then I can either solve this by factoring or by using the quadratic formula. I'm going to take out a greatest common factor of 4x, and then I can set each of these factors equal to 0 to get my x values. So I can see that x will be 0 for this factor and x will be 1 for this factor. We now need to substitute each of those values back into one of the original equations in order to solve for y. So this one looks a lot easier to work with than this one. So I'm going to substitute back into this equation. So we're going to start with the first solution. So if x is equal to 0, I'm going to go negative 3 times that x value of 0 and then minus 9. Negative 3 times 0 is 0, which means y is just negative 9. So my first solution is 0, negative 9. We're going to write that as an ordered pair. And then my second solution, if x is equal to 1, we're going to do the same thing, substitute a 1 into the place of x to try to solve for that y value. Negative 3 times 1 is negative 3, minus 9 is negative 12, and there is the second solution. Now it's really important that you verify each of them. So let's begin with if x is 0. If x is 0 and I substitute it into this term, 0 times 3 is 0, that term is gone. Negative 9 is my y-coordinate. I'm going to substitute negative 9 in here. Negative 9 equals negative 9. That solution works for the first equation. And let's try the second one. So substitute 0 in for the place of x. That term's gone. That term's gone. And again, negative 9 goes in for y. Negative 9 equals negative 9. So we know that that first ordered pair is a solution. And then we're going to do the same thing with the next one. So if I substitute a 1 in here, 3 times 1 is 3. 9 is now negative 12. 3 minus 12 is negative 9. That's verified. And then the second one, I'm going to put this 1 in the place of an x. So 1 squared is 1 times 4. That term is 4. And then minus 1 is going to be 3 plus y, which is negative 12. So this is equal to 3 plus negative 12 is negative 9. That solution is also verified. In this first example, we substituted one equation into the place of the other. In the second one, we're going to now solve by elimination. You could also do this by substitution, but let's just review how to do elimination. So remember, we want to eliminate that y variable. So I can see that if I multiply this entire equation by 2, we will end up with this, and then we can line up the terms. So this particular equation doesn't have an x squared term, so I'm going to leave that blank there. Line up the x's, line up the y's, line up the constant terms, and I'm trying to eliminate y. I can do that by subtracting those two equations. So x squared minus nothing is still x squared. We have 1 minus 10x is negative 9x, negative 2y minus negative 2y. Remember, a negative times a negative becomes a positive. So it's essentially negative 2y plus 2y, which is 0y. And then we have 0 minus 20 gives us negative 20. And now, again, we have that quadratic. So we're going to move everything over to where that squared term is positive. Check if it factors, because if it factors, you're going to save yourself a lot of extra time. Are there two numbers that multiply to 20 and add to negative 9? And thankfully there are. So we know that our solutions are going to be x is equal to 4 and x is equal to 5. We now need to substitute back into an equation. So if I take a look at my equations, I can see that y has a coefficient of 1 here. So I'm going to move that y over and then move that 10 over, and I can quickly generate my other values. So I'm going to rearrange this into y equals 5x minus 10. I'm going to substitute 4 into the place of x, so 5 times 4 is 20, minus 10 is going to give us a value of 10. My first solution, when x is 4, y is 10, and don't forget, we're going to write that as an ordered pair. My second solution, if x is equal to 5, I'm going to substitute it into that same equation, so we're going to go 5 times 5, and then minus 10. 25 minus 10 is going to give us 15. So when x is 5, y is 15. And make sure that you substitute both of them back into each of those equations to make sure the left side equals the right side. This is the same equation. We just solved it by elimination, but you could also use substitution. So we can see at this point we have a negative 2y and a negative 2y. So if we isolate that negative 2y, I'm going to move that 10x to the other side, and then I'm going to do the same thing with this one. I'm going to isolate that negative 2y, and then we can essentially substitute one of those equations into the negative 2y in the place of the other. And then when we see this is a quadratic, move everything over to the side where that's positive, we're going to end up with the same quadratic equation. If we have a quadratic-quadratic system, again, look for those y's. I have a y here, and I'm going to move this y over to the right-hand side so that I can set those two equal to one another. So the first equation, y equals this, the second one, y equals this, and then I can see that it's a quadratic, so I'm going to move everything over, beginning with my smaller coefficient. So everything's going to come over to the left-hand side, and we're going to set that equal to 0, and then check to see if this is factorable. Are there two numbers that multiply to negative 10 and add to positive 3? We can get those numbers 5 and negative 2, and then again 2x times x gives us that 2x squared. You're going to say 2x times what number will give us one of those factors, and we can put a negative 1 here, so that's that one. And then we're going to say 1 times what will give us that 5, and you can quickly FOIL it out to make sure you factored correctly. Set each factor equal to 0, and that gives us the two solutions. Now when you go to get y, you can substitute them back into either equation. I'm going to use the first one, and so we have to do each of these. So beginning with if y is equal to negative 5 halves, so I'm going to put 6 times that negative 5 halves squared minus negative 5 halves plus 1. And then we're just going to go through algebraically and solve that equation to get our y coordinate. And then once you get the x and the y, make sure that you put them back in to verify, does the left side equal the right side? And then we're going to do the same thing with the second solution. X is equal to 1, so we're going to substitute 1 back into that original equation and generate the y coordinate. So this particular system has two solutions. And then with my last one here, because we're now dealing with d and h, we tend to list those variables alphabetically if they're not x and y. I can also see that I have a d squared and a d, which means d is in the place of x, h is probably in the place of y. So if we're trying to isolate y, I've got a 3h here. I can multiply this entire equation by 3 to also get 3h here. We can then set those two equations equal to each other. They're both quadratics, so I'm going to move the smaller coefficient over. So this is going to become 14d squared, and then we're going to move all those other terms over to get 0 on the left. Check if this is factorable. There is no greatest common factor. If we multiply 14 times 9, are there two numbers that multiplied in 126 and add to negative 28? There are not, but even if this is factorable, if you can't easily identify those numbers, you can always go into the quadratic formula, which is what we'll have to do. So we have our terms lined up. This is a, this is b, and this is c. So we have negative b, so we're going to take the opposite sign of that b value, plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. If we simplify that radicand, we get 280, and then I can multiply the denominator to get 28. You're looking for the largest perfect square we can pull out of here, which happens to be 4. The square root of 4 is 2, so we're going to pull that out. And then check all of your whole numbers. They're all divisible by 2, so we're going to divide them all by 2. And you're simplified when there's no more perfect squares in the radicand, and when you can't divide those numbers any further. So we've got the value for d. One solution is 14 plus the square root of 70 divided by 14. The other is 14 minus the square root of 70 divided by 14. Now we need to solve for h. Now at this point, you could definitely take this solution, 14 plus the square root of 70 divided by 14, store that as x in your calculator, and then I would type in 5 times the variable squared minus 10 times the variable. That will give you the h coordinate, and then do the same thing for 14 minus the square root of 70. Remember to press equals, divided by 14, store it as the variable in your calculator, and then enter that 5d squared minus 10d to get the other coordinate. I'm going to go through algebraically just so you can see how we would do this. So again, this is the equation I'm going to substitute into. I'm going to begin with my positive solution. So 14 plus square root 70 divided by 14, and I'm going to enter that in the place of both d's in order to solve for h. And now we're going to go ahead and simplify this. This is just for fun, so don't get too daunted by this. This is just how we could do it algebraically. All right, so once we've got it substituted in here, I can see that in this bracket, 14 divided by 14 is 1, and the square root of 70 over 14, I'm going to leave that as is. And then in the second bracket again, 14 divided by 14 is 1, and then I'm going to write the second piece as just the square root of 70 over 14. I can only add like radicals, so because I don't have a radical here, I'm actually going to FOIL this out. So I'm going to square the first term, 1 squared is 1. I'm going to double this product. So 1 times the square root of 70 is still 1 root 70 times 2 gives me that 2 root 70, and the denominator is going to stay the same. It's going to stay as 14, and I'm going to square the last term. So squaring will cancel that square root, leaving me with 70. 14 squared is 196. And then in this bracket, we're not foiling because it's not squared, but I can distribute that 10 in. So negative 10 times 1 is negative 10. And then I have a negative 10 times the square root of 70 over 14. I'm going to get rid of these brackets here by distributing that 5 in. So 5 times 1 is 5. This particular one I can reduce. 2 over 14 is just 1/7. So I'm going to have 5 times the square root of 70 over 7. And then 5 times 70 is that 350. And the denominator here is 1 times 196 is that 196. And then again, I can reduce this. 2 will divide evenly into 10 and 14. So this is going to also become 5/7 times the square root of 70. So now I can see that term and that term will cancel out. I can reduce this fraction, and now we've got 5 minus 10 is negative 5. This reduces to 25 over 14. Find a common denominator of 14, and then we can get that numerator. And when we add those together, we end up with that as a result. So when x is this value, y is this value. And now we're going to take our second solution, 14 minus the square root of 70 over 14, and we're going to substitute that into the place of d and solve for h. So when we do that, you're going to notice we end up ultimately with the same solution. On our first one, this was a positive, and this was a negative term. On this one, we have a negative and then a positive. So the signs are different, but they both end up canceling, and we do get the same solution. And again, if you want to put this in your calculator and just get that negative 3.21, etc., that's okay.